Hello friends, welcome to Susan and John MathTube. It's me, Deepak George, and this is lesson number 2 in Asymptotes. In lesson 1, we learned about rational functions and its asymptotes. But today we are going to do something very important in your syllabus because they will ask this for 4 marks if they ask, and I strongly suspect they will ask this because this had been a repeated question in the previous syllabus. Anyway, what are asymptotes? I hope you remember the answer. Asymptotes are straight lines, and they are lines which will meet the curve at infinity, but it will move along with the curve. Anyway, today we are going to learn asymptotes of algebraic functions. Anyway, algebraic functions means implicit function. So I have a long procedure here. If you want the procedure, you can take screenshot. Anyway, I'll work out one problem and make you understand the procedure. Anyway, before we start, if you know anyone who is facing difficulty in mathematics, contact us. Let it be GCSE, A levels, IB, contact us. Okay, so let's go back to asymptotes for algebraic curves or implicit function. So you can take screenshots here, simplify the equation, find the degree of the equation. So I'll scroll slowly. You can pause and take screenshots. Okay, let's start with one problem. So once more, let me make it very clear. Type 1 means asymptotes of rational function. Type 2 means asymptotes of implicit function. And let's learn this procedure within 20 minutes. Okay, the first thing to do is to simplify the equation so that you will be able to see the equation in term by term format. And then what you do is you find the degree of each and every term. And when you find the degree, focus only on the variables x and y. Normally they will give you x and y. So degree means the highest power or the sum of the powers of the variables if it is in product form. So degree 3, degree 3, degree 2, degree 1, degree 1, and no constant term, no degree 0 term. Anyway, degree means the highest power, so I wrote the degree. Now I know that the number of horizontal asymptotes plus vertical asymptote plus oblique asymptote will never be more than 3. I'm sure that I will not get 4 asymptotes in this problem. Okay, so our job will be, first we will check whether it has horizontal or vertical asymptotes. Because if you get 3 horizontal or horizontal plus vertical to be 3, then you don't have to worry about oblique. Oblique will not be there. Okay, and for that there is a test. The test is very simple. You scan the equation term by term. You look at the equation term by term. If you see x cube and y cube, you can be very happy because you don't have to calculate vertical and horizontal asymptotes. But in this problem, don't be too happy because I am not able to see x cube. I am not able to see x cube. And that means the horizontal asymptote will be present. Once more, let me tell you, when I taught you type 1, I gave you the logic, I even showed you the graphs, etc., etc. But in type 2, I'll teach you just the procedure because don't forget, you're not a mathematics student, you're an engineering student. And for an engineering student, these topics are mathematical tools. Okay, so you don't have to go too much behind the mathematics for these things. This is beyond the scope of your syllabus. Okay, once more, let me tell you the procedure. You scan the equation term by term. If you see x cube, be very happy because you don't have to calculate horizontal asymptote. But I cannot see. So you have to calculate the horizontal asymptote. But y cube is present. That means I don't have to calculate vertical asymptote. And the method to calculate horizontal asymptote I have written here. The method is you find the terms containing the highest powers of x and equate it to 0. Okay, I'll tell you how. And by the way, if it is vertical asymptote, replace x with y. That's all. So, how am I going to find the horizontal asymptote? Okay, I'll take some color pens. Okay. Does it contain x? No. So, I'm going to ignore it. Does it contain x? Yes. Does this contain x? No. Does this contain x? No. Does this contain x? Yes. So I'm going to be focused on this and this. But it is written highest powers of x. So I am not bothered about this. So I'll be worried only about this part. And what is the coefficient of the highest power of x? Minus y. And the right side is equal to 0. So that is how I obtained the horizontal asymptote. So right now I found that there is one horizontal asymptote. But total number of asymptotes is equal to 3. So I have to do further. So now what I'm going to do is I'm going to search for, so look at this. I found that there is one horizontal asymptote and no vertical asymptote. So I am expecting oblique asymptotes. I am expecting oblique asymptotes. It may or may not be there. Okay. Anyway, now let's go for the procedure for oblique asymptote. Once more, let me remind you, I'm not teaching you the logic. I'm giving you the working rule. Okay. So for that, what we do is we will write the terms of degree 3 as phi 3. Can you see? Terms with degree 3. If you want, I'll color it for you. This one. Degree 3, degree 3. And terms with degree 2 will be called phi 2. And terms with degree 1, degree 0, then what you do is you replace x with 1, y with m. So you'll get this. If you want, I'll show it. You just replace x with 1 and y with m. So that gives me m cube minus m. Anyway, you'll be able to form up to this. I'm sure about that. Now you have to, memorize a few formulae. So once more, let me tell you, we are trying to find the oblique asymptote. What I did is, the degree 3 terms will be called phi 3, degree 2 terms will be called phi 2, degree 1 term will be called phi 1, and the constant term will be called phi 0. And in the question, there are no constant terms, so I put 0. And then you replace every x with 1 and every y with m in any problem that you're planning to do. Let it be any problem, this is the procedure. Okay, now bad news, but I'll make it simple for you. You're going to mug up a few formulae. The first equation that you're going to by heart is phi 3 is equal to 0. And there's an easy way to remember this. The question had degree 3. That is why I wrote phi 3 equal to 0. The second equation will be c divided by 1 factorial phi 3 dash plus phi 2 is equal to 0. The third equation will be c square by 2 factorial phi 3 double dash plus c by 1 factorial phi 2 dash plus phi 1 equal to 0. And the last equation will be c cube by 3 factorial. I think now you are able to see a pattern. Come on, can you guess? Phi 3 triple dash. Actually, we are writing the same thing again, and every time the dash increases and the power of c increases. So what will be the next one? C square by 2 factorial dash will increase. Plus c by 1 factorial, a dash will appear, and the last one phi naught equal to 0. So I want you to by heart these equations. And by the way, we may or may not use all the equations, but remember, oblique asymptotes means they are slant asymptotes. Those who watched video number 1, the last video will remember there are 3 types of asymptotes. And oblique means slant asymptotes. Slant asymptotes means they will be in the form y is equal to mx plus c. And our job is to find m and c. So the working rule that I am giving you will give you all the values of m and c. And remember, when the degree is 3, there will be 3 plus 1, 4 equations. How many equations? 3 plus 1 is equal to 4 equations. If the degree is 4, there will be 5 equations. But once more, let me reiterate. We may or may not use all the equations. Anyway, the first equation will be always used to find the value of m. And once you get the value of m, we will use the remaining equations to find the value of c. Okay, so what is the use of the first equation? To find the value of m. So phi 3, where is my phi 3? This is my phi 3. So I'm going to write phi 3 equal to 0. I have already written here. So phi 3 is equal to 0. That gives me this, and I got this. Now something very important which you may or may not have learned. So look at this, we have a cubic equation here, and I showed you a process. But what I feel is many students struggle in solving cubic and 4th degree equations because you have not learned these things systematically. But don't forget, you are an engineering student, not a pure mathematics student. So you have to embrace technology. Okay, so I have kept something for you here. So I hope you're using one of these calculators or maybe an older version, but I'll strongly recommend use these calculators because you can solve up to 4th degree equations. Okay, so I kept both the calculators here side by side, and I'll show you how to solve a cubic equation. What you do is you press the home button in this one, and you press the menu button here or the home button here. I think I have to use another color. Okay, and then take equation and take equation. In this calculator you have to press alpha and A. In this one directly press OK and it will take you to this menu. And I'm solving a polynomial equation. I'll choose polynomial equation. And then I will choose cubic equation because this question, the question I showed you here, can you see the question? It is a cubic equation. So I'm selecting degree 3. In the old calculator you have to type 3. In the new calculator you can just use this arrow button and take 3. And then look at this. This is the equation that I'm trying to solve. So I'm plugging in all the coefficients. Please remember, you have to plug in all the coefficients. Here, can you see? M cube plus 0m square minus m plus 0 equal to 0. This equation is too simple. You can solve it without a calculator. But in exam, they ask tough questions. So be ready with a calculator. And you have to enter the coefficients 1, 0, minus 1, 0. Anyway, here I have a different equation. I entered the coefficient and my calculator will give x1 value, x2 value and x3 value. Now, one warning. This is very important. Your calculators will not give you the repeated root. Your calculators will not show the repeated root because look at this. In mathematics, we learned that if you have a cubic equation, there will be 3 roots. Maybe alpha, beta, gamma, distinct roots. Maybe alpha, alpha, gamma. One of them repeated and one of them is distinct. Or maybe alpha, alpha, alpha. If you have a 4th degree equation, then there will be 4 roots, alpha, beta, gamma, delta. Or maybe it can be alpha, 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 and 1 will be non-repeating. So your calculator cannot show repeated roots. So I'll give you one example for that. I took this equation. Come on, put it in equation mode. I'm not showing those steps. You can just check with the video and look at this. I got x1 in both the calculators. I got x2 in both the calculators, but it is not showing x3. Check it in your calculator. Your calculator will not show x3. So what you do is you write the values of x1. What is x1? Minus 1 by 2, and x2 is equal to minus 1. Now you differentiate the given equation. That gives me 6x square plus 10x plus 4 is equal to 0. I know that a cubic equation will have 3 roots, but I got only 2 roots from the calculator. So one of them will be repeating. So all I have to do is I have to plug in this root into the derivative. So I'll get 6 multiplied by 1 by 4 plus 10 multiplied by minus 1 by 2 plus 4 is equal to 0. Oh no, I'm not getting 0 equal to 0. So this does not satisfy the derivative. So this is not the repeated root. Now try it with the other one. So 6 into 1 plus 10 into minus 1 plus 4. Oh, now I am getting 0 equal to 0. Now I know the roots are minus 1 by 2, minus 1, minus 1. In the next video, I'll work out some very important questions here. At that time, we will focus on repeated roots. Anyway, in this question, the roots are not repeated. You can be very happy, the roots are not repeated. All the roots are distinct, distinct, distinct. Now, once more, let's go for this equation. I told you there are 4 equations. And the first one will be used to find the values of m. And I got m equal to 0, a distinct root. So if I want to find the c value, I'll be using this equation. I'll color it. I'll be using this equation. But if the roots are repeating, for example, if I get m equal to 7, 7, it is a repeated root. It repeats 2 times. Then I will use this equation to find c. Suppose my values are something like 10, 10, 10. Then I will use the c cube equation. Anyway, in this question, you saw that all the roots are distinct. So I'm going to use only this equation. So look at this. I'm going to write m equal to 0. So what's the first equation? C by 1 factorial, phi 3 dash plus phi 2 equal to 0. So c by 1 factorial and phi 3 dash will be, I have the value of phi 3 over here, 3m square minus 1. 3m square minus 1 plus phi 2. What is the value of phi 2? I have it here, 2m square plus 2m square equal to 0. So what I do is I'll plug in m equal to 0 here. C into 0 minus 1 plus 0 equal to 0. So I got c equal to 0. So my equation will be y equal to mx plus c. That is y equal to 0x plus 0. Now look at this, m equal to 1. It is a distinct root. It is a distinct root. So what I do is I'll put it in the same equation, and it gives me another value, and I'll get c into 3m square minus 1 plus 2m square equal to 0. So c into 3 minus 1 plus 2 equal to 0. So 2c equal to minus 2, c equal to minus 1. So I'll write my answer is 1 into x minus 1. Similarly, you try it for m equal to 1. Anyway, at the end, I got 3 asymptotes, 1, 2, 3. In the next video, we will focus on three important questions in type 2. Don't forget, type 1 is rational, type 2 is implicit. We just learned the outline of the method. In the next video, we will focus on three different problems in implicit. So till then, my friends, bye.